Hello, my name is Zachary Magnotti. The title of this project is Super Smash Bros. Machine Learning. And the basic idea is that the character that you play as in a game of Super Smash Bros. Makes a huge difference on the way that you play the game. Some characters are faster, some characters are slower, they all have their unique combos. And if the way that you play the game is determined by the inputs that you send to the game with your controller, if you only had access to those raw inputs straight from the controller, is that enough for a machine learning algorithm to detect the character that player is playing as? So a little bit of background about the data. Super Smash Bros. Is 20 years old. It's an old game. There's no online matchmaking. There's no replay files. But we live in the future now, and there's an open source emulator called Slippy that allows for both online play and, most importantly for me, automatically saving replay files of the games that you play. Those replay files, of course, are going to contain the inputs from both players. So the data set that I'm working from is a public data set of these replay files, just under 100,000 of them, all tournament sets, all not professional games, but high-level competitive games. They're all over 30 seconds, and they're of varying skill levels. And what I'm curious about is, are my results going to mirror the tier list and the popularity of the different characters in the game? The idea being that characters that are more effective and win more games and are more popular are both going to get more representation in the data set, and I'm assuming a stronger signal of a defined playstyle. So the model that I'm using is a temporal convolutional neural network. I'm using 3 one-dimensional convolutional layers and 3 standard dense layers with a total of about 625,000 trainable parameters. And as far as results go, overall, my model was about 92% accurate on the data set overall, and 98% accurate on just the top 8 characters, which is way better than I was expecting. Here's a quick look at the confusion matrix. You can see there's a very strong diagonal, and when it is confused, there's about 5 characters that it tends to confuse everybody with. If it's not sure about somebody, then it tends to throw them into one of those 5 categories of Captain Falcon, Fox, Marth, Jigglypuff, and Sheik. But other than that, a very strong, true positive diagonal. Here's just a quick glance at the recalls. This is close to what I expected. Most of the most popular characters are over here on the top left with a very high recall, and it tapers down from there to the least popular characters over here, which are not accurately detected at all. Here's a quick look at the precision. Funny little note here is that the only character that has a 100% precision is Roy, who's one of the worst and least popular characters. And I checked out the data set here. There were only 3 Roys that were predicted in the test data set, and they were all correctly predicted. But there were about 30 Roys total, and only 3 of them were detected. So this is just an example of the difference between accuracy and precision and why it's important to look at both. Lessons I learned, most of my time was spent cleaning and preparing the data. The data pipeline was by far my most severe bottleneck. I had so much data that it was so difficult to deal with. But using MongoDB and generator functions to efficiently store and read from the data set during training was the key to getting the model up and running. All the data in the world isn't going to save you if you can't wrangle it and effectively use it. So next steps, minor feature engineering, maybe combining buttons on the controller that do the same thing to simplify the inputs to the model. I might try training the model on a data set that only has those top 8 characters to see if it improves the accuracy. Or maybe train the data set on train the model on a data set that only has the low tier characters to see if that will let it catch up on the characters that it didn't get to see very much of in the main data set. And I would also like to investigate if a similar model can detect player identity, i.e. who is playing the game, rather than the character choice in the game. And I'd also like to come back to this project with a more sophisticated machine learning algorithm, something like a recurrent neural network, and just see if it gives me better results. So thank you very much for watching this video and seeing my presentation. And special thanks to these players for donating their games and their valuable game knowledge. It was very helpful. Thank you very much.